Okay, so this tutorial is on what I get a lot of questions on, which surprises me sometimes because I guess I expect you guys to come to class knowing how to read graphs and charts and how to make them. So let's begin. So this question asks, an experiment studies the effects of an experimental drug on the number of offspring a mother mouse has. 10 female mice are given the drug and then impregnated. The number of mice in the litters is compared with litters of mice that did not take the drug. So group A got the drugs. Group B didn't. And if you notice, sometimes it's more, sometimes it's less, but it's not consistent. You could do an average, but I even think if you did an average, it really wouldn't show you very much because two numbers here are different. Two numbers, this one's more here, this one's two numbers, they're the same, this one's actually less, that's 3. And then, of course, you have some abnormals which are extremely high. I would honestly say, just looking at this, you don't have enough data to tell you the drug works. So let's, okay, and even if you look at the graph here, and this is just a bar graph, in my opinion, and as somebody who's done research before, I would honestly say that you cannot conclude with reasonable certainty that the drug worked. Okay? Next graph. A type of feed claims to boost the growth rate of cows. The feed is tested on 2 twin newborn cows. Bessie receives the experimental feed and Bertha receives the regular corn feed. Their weights are recorded below. So we're going to graph the data for Bessie and Bertha, and we're going to label it XY. You're going to want your months down here and your weight here because your weight is dependent on the months. And then both cows ended at the same weight, but the did the experimental feed change the way they gained weight at all? Describe your conclusions and why it's important that the experiment use twin cows. So let's look. It's important they use twin cows so that the genetics are the same, so that we aren't introducing other variables. So when we graph these, we see that Bertha is a red line, and she had a peak and then just kind of leveled out, while Bessie did at a pretty steady increase. So really and truthfully, the experimental feed didn't make a difference in their weight gain. It didn't make one cow gain more weight faster than the other, which is what I would think is why I would pay extra money for experimental feed. And this line graph really proves that. Okay. Next one. According to the graph, which town grew the fastest? So when we look here, we can see that Riverton went way up, and it grew the fastest. All I'm doing here is reading the graph. Which town declined in population? So for here, we're looking for somebody whose 2000 population is less. And if you didn't know this, the 1990 population is first, then the 2000. So here, that one increased. This one, there's a decrease. So that's Westfield. Okay. And the next one says, which one had the smallest change? Well, this was actually very dramatic. This one was dramatic. This one was pretty dramatic. This one too, pretty dramatic decrease. This one looks like it only went up about 800, and that looks like it's actually going to be the winner because this one here on the end went up a little bit more. So your correct answer is Ashenvale. Okay. And the next question says, what is the population of Woodland in 2000? And so all I have to do is go across. And if you notice, it falls between 800 and 1600, and the difference between them is 800, and halfway would be 400. So 800 plus 400 is 1200. So approximate population of Woodland is 1200. Okay, I hope this is helping. According to the graph, which organism has the most number of species? Well, if you look, it would be invertebrates, because insects are invertebrates and then other invertebrates. Okay. So, and here, even though you can't see this, this says plants, and plants, last time I checked, were not invertebrates. So if this is 50, this was 25, this is maybe 5%. So we would say 95% were invertebrates. Approximately what percentage are vertebrates? Well, that's the percentage that's left, and that's 5%. Okay, and again, all I did here was say, okay, this has to be 25 because this is 50, and that's half of that. This has to make up to be 25, and this is most of it. So a good approximation is assume that's 20%, and that's 5%. Okay. Our next question says, the number of nurse sharks, the population of tiger sharks off the coast of Florida was recorded over several months. The following data was taken. So here's the data. And they also took the number of nurse sharks, but the data is really bad. So they're going to ask us some questions about the data. The best way to do this is to actually graph it, and you're going to want to do a line graph we did with Bessie and the cow and compare it. So when we do this, we actually see that here we are, the tiger sharks, and then we get a line that just says, hey, this is about worst fit. This is your best fit line for what the data is showing. And so approximately, if this is March, this would be April. We're just going to say March, because it's not quite to April, is where they will be equal. And all that is an approximation. Okay. The other thing I can say, as the nurse sharks decrease, the tiger sharks increase. That's kind of an interesting note there. Anyway, I hope that data helps, and I hope that watching this tutorial helps you understand better a little bit about reading graphs and charts, and of course I'll be putting more up to better help you.